Hello everyone, my name is Ssesaazi Isma, a student of Victoria University, pursuing a Bachelor's of Computer Science, Bachelor's degree in Computer Science. So I'm here to take you through simulation and modeling. Subscribe and follow my YouTube channel. We have our question, and here it goes. You have been selected to simulate the checkout process in an e-commerce store, such as a small gift shop. The setup includes the cashier and one blind customer waiting for service. The service delivery sends the payment to key performance measures. The average time customer spends in the system, both waiting and being serviced, the percentage of time that the checkout clerk is idle. Assumptions: we have the arrival times, we have the service time. The requirements: we have create an Excel spreadsheet. The simulation should calculate to measure zero performance. Instructions: we have simulate 20 customers, simulate for 3 hours, then use here data table to generate 50 duplication of the simulation. Write a brief report. Here we should get a GitHub link. We will save as SM CW question 1. Then we should use a screen file, save and provide URL links GitHub. So I'm going to take you step by step. Our step 1, we have for the first thing we should do, here is a breakdown. This is our Excel now. Here is a breakdown of how you can simulate the checkout process for the e-commerce store in MS Excel to answer the questions. Setting up the simulation, you need to simulate 20 customers arriving over a 3-hour period and calculate 2 key performance measure: average time in the system, W, and the percentage of time the checkout clerk is idle, 1 minus him. Step-by-step guide. Step 1, generate random numbers for interarrival and service time. Arrival time, where we have 1:15. This is what they mean. The arrival time, random number, interarrival time, random numbers from 1:15. For random numbers, we have the formula here. It is run between. We should use a formula run between 1:15. Once you generate this, it is the formula you use and generate all these random numbers from 1:15. As you see, they run from 1:15. So we go to we have service time. Service time is here, and service time is also in random numbers, where we have from 1 to 8. From 1 to 8, as it was given in the question. You should generate this in your as a formula, then it gives you this, because Excel is automatic. Step 2, simulate the arrival times. Arrival time is based on the interarrival times. Arrival times, this one here, arrival time is based on the interarrival time. Assuming the first customer arrives at time 0, you can calculate the subsequent arrival times for the first customer. Arrival time is equal to 0 for subsequent customers. Arrival time, where arrival time is equal to previous arrival time plus the interarrival time. This arrival time is equal. Just assume this was 1. The customer arrived at 1, so just say this is C2 plus B3 to get the arrival time, which is equal to we get this C2, this one plus this, we get 12. We get 12 plus 11, like that, plus B3, like that. You follow the procedure as it is given here. So The second thing we should look at it is step 3, calculate the service start and end times. Service start time is the maximum of the service time, the maximum of, we should get the random between. Service start time is the maximum of C5 and F4, or the maximum of C2 and F1. So whereby service start time is the maximum of the arrival time and the previous customer's service end time, because the cashier can't start serving a customer before the previous customer is done. Maximum is arrival time, previous service end time. Service end time is service start. Service end time is service start time plus the service time. Service end time is equal to service start time plus service time. Service end time is here. Yeah, for service time we get the D3 plus E3, and the step 4, calculate the time in system W for each customer. Time in system W is difference between the service end time and the service arrival time. This one we get the F2 minus C2. So calculate the idle time. The idle time is the time the cashier is not serving anyone. This is the time between the previous service end time and the time arrival time and the next arrival, then the next arrival time. If the next customer arrives after the cashier is done with the current customer. So with the idle time we get the maximum from 0, C3 and F2. Once you formulate this formula, you get the results here. Since time is not our best ally, I'll take you through the average time, the average customer time, where we get the average of H2 to H21, the total simulation time. We get the simulation time was given and it is 180. Total idle time, we get the maximum from 080 minus the sum of the D2 proportion to D21. So for the proportion time, percentage time is idle, 1 minus 1. Total idle is time divided by simulation time for the 3 hours, or 180 minutes times 100, as you see here. So step 7, our last step here, we go on sheet 2. The sheet 2 here, as we have to duplicate the simulation 50 times. Here these are random numbers from 1 to 50, where we get row minus 1. Once you put this formula, it generates for you these random numbers from 1 to 50. Then we come and say use the Excel data table feature to generate the Excel data table feature. These are a data table features where we have multiple duplication time. Set up one row with the reference to your final results, i.e. the average time in system and percentage idle. Create a list of number equal 1 to 50 as a column of duplication indices. Use the data table features in Excel to simulate the 50 duplications. To do this, you should go to data, then you go to what if analysis. After what if analysis, you go to data table. It generates for you all this. To get the proportion time server I is idle average time in the system. So once you do that, for the column input cell, leave it blank. This will run the simulation 50 times using the random numbers. I remain Ssesaazi Isma. Thank you for the opportunity. Please subscribe and follow my YouTube channel for more to simplify more of the work. Thank you.